So Matt, what do we want to sketch today?
Good morning. So today we're looking at a project that we're building on Canisius Lake. It's a house that is being built on an existing foundation, and we're running into a dilemma with a retaining wall on that project. So as usual, we have to come up with solutions that are the most effective in terms of, cost and time and budget and all these things. So we're gonna hop on the iPad and we're gonna work our way through it. So right now, there's basically the existing foundation, the corner of the house. The entire house kind of is positioned like this, and it's got a driveway that kind of comes up from the road edge. The road edge is kind of close here. And the driveway is kind of bermed up against the existing house foundation. We demoed this. It was a garage. We demoed this, we updated the foundation a little bit, and now we've built a house on it. It's actually framed and in position. And the plan is that they're still gonna maintain this driveway, but the existing driveway kind of extends past the house a little bit on this side. And then it sort of returns down like this, and then there's another driveway that swoops around and goes way, down to the existing house on the lake side. This is an ADU, an accessory dwelling unit. The homeowners are going to be living in this as their retirement home, and then the rest of their family is going to be living in the lake house. But this moment right here is becoming a bit of a problem that we need to deal with. As we got into the project, we realized that this existing retaining wall here is starting to rot. It was built out of lumber, pressure treated lumber years ago, and now it's just decaying and falling apart. The plan for the new build is that there's going to be a new deck that's positioned right here. And we have a series of foundations in place already that's going to receive this new deck, and they'll be able to sort of walk up to the front door using this deck, and the foundations are roughly placed here, here, and here. Now those are in position right now. This deck is not built, but we really got to take a careful look at this situation right here and come up with a solution that, like I said, that's logical, that's economical, that just makes sense. If we were to, let's just say, this is the ground plane. Our existing pier kind of comes in like this, and it's got a base to it like that. Our future deck is going to exist somewhere in this territory like that. And then the existing wall that's rotted kind of lives right here. So our solution for this is that we would like to get a new retaining wall in place somewhere in this area. And if you're to go below frost depth, like you need to in Western New York, for the footing, that means you're going to go way down like this, and then this footing is going to be a good 8 feet or more from the bottom of the deck, which means we're almost like 5 feet below grade in this area. And being how close it is to the house and how tight that space is, we just don't have space to do that large of an excavation. And when you're looking at a foundation detail like this, a retaining wall, if you go super high, I'm going to draw this at a little bit different scale, and then you have a keyed footing, which means you sort of go back in space a little bit, and the aim is to have the dirt sort of pile up and apply pressure to that footing. Now, if this is a really tall wall, the problem is the lateral forces from the soils are going to be able to push the higher they are on this, so this thing will begin to fail in time. So what we want to do is come up with a solution that deals with that somehow. So again, another layer, we're going to go up. My thought is sort of hybridizing a solution that we have for slab-on-grade homes that we've been using. And we see this detail a lot in, like, you know, passive houses and things like that. But essentially what it is it's a layer of foam. And then on top of that layer of foam is where you would pour your footing. And then on top of that is where you would sort of not center your retaining wall, but you would put it off to one side, because again, you want the dirt that's mounted up on this side to be applying a pressure to this footing, kind of holding it down and stopping this entire thing from rotating. On the low side, you know, we can go a little more shallow with this footing, because during cold times of year, when the cold is trying to migrate under this footing, this insulation detail is going to stop that migration from happening. It's going to hit here, and then it won't be able to sort of travel underneath the footing and create uplift, which is what we're trying to avoid. But this is a nice solution because, for a couple reasons, it gives us this upper section of retaining wall that's much shorter now, right? It's a much shorter lever that this pressure is being applied to. And we still have this really nice size footing on the bottom that we can use to sort that out. So one more time, I'm going to add a layer, add some opacity, and that's the rough idea for it. So I really love working on the iPad just simply for scale. So what I can do is I can strike a line, I can set the scale really quickly. I'm going to just put in 4 feet and hit enter. So now that's registered as a 4 feet long line. So that's going to be my 4x8 sheet of insulation board. And then I want this footing to be enough so that we'll have to run some calculations on that, and I'll do that once I get the sketch complete. But I want to run that footer to be probably like 3 or 2.5, let's say 2.5. I'm gonna split the difference because I'm undecisive about the two, and we're gonna go about 8 inches deep with this. So that's 1 foot right there. So that's the footing, and the wall I would want to place, that's also going to be about an 8-inch wide wall. And I want to place that only a few inches away from this side. So I'm going to go about 6 inches, and then we'll go about 8. And then as far as the height, this thing's going to be about, it's not going to need to be that tall, honestly. Only needs to be a few feet. So now that I've used the ruler to sort of get the proportions correct, I can kind of begin to finish that sketch. Well, I said it's not complete yet. We'll finish it now after I take a sip of coffee. So other things that we need to be thinking about with this retaining wall is reinforcement. So we're going to want some rebar in here to connect the two sections, the wall and the footer, together. And that's going to really reinforce that bond between the two. We'll also do the same on the front and run another L-shaped reinforcement that runs all the way up the wall. And then I'm going to start to add in just a little bit of details showing, you know, what's concrete and what's going to be insulation. So now we're going to add some dimensions to those dimension lines, and I'm going to keep it, you know, it's feet and inches, but I'm just going to label everything in inches just to make it clear. I'll just add a couple of leaders quickly, just indicating the size of those and dimension of those. So there we have it. But I feel pretty good about this. We have to run some calculations really quick, and it'll be a long-term solution that balances the budget. It's the most economic option that we have. Fits within that tight confined space that we have to work with, and will be a long-term lasting solution for them. Thank you.